Today is lesson 28 in your math daily review. So let's get started with number 1. And there's actually a mistake in number 1, and I'll explain it. So it's talking about angle measurements here, and each of the angles are labeled with letters. So you have G, R, B, and W. Okay, let's start with actually angle measurement BRW, the second one here. It says it's 30 degrees, so let's find BRW. BRW, so it's talking about this one. It's talking about this one here, and that's 30 degrees, and it tells us it's 30 degrees. Okay, and I'm going to go ahead and erase that now so we can see. So for GRW, it says it's 70 degrees, but let's check to see if that's actually true. G to R to W, so this whole angle here, is that only 70 degrees? No, it's not. It's actually 70 plus this 30. So 70 plus 30 is 100, so this should be 100 degrees actually. Okay, and now I'm going to erase this so we can figure out the last one, which is what we're actually what they wanted us to figure out. So angle GRB, G to R to B. What's that measurement? That one is 70 degrees. There you go. All right, number 2. Frank has 67 baskets of 83 toys. Of 83, so that means each basket has 83 toys. That's a lot of toys. Okay, how many total toys does Frank have? Total, so we're multiplying here because each basket has 83 toys in it. Okay, so we're just going to do, I'm going to do standard algorithm here. 7 times 3 is 21. 3 times 6 is 18. Plus 2 more is 20. And I'll do the second digit in blue. So I'm going to add that 0 because I'm starting one digit to the left. These are my tens, so I'm adding a 0 for that place value. 8 times 7 is 56. Write in my 6, carry my 5. Now 8 times 6 is going to be 48, plus 5 more, plus 2 more is 50, and then plus 3 more is 53. See, I'm doing this math right there with you guys. And now I can find my total. 1 plus 0 is 1, 6 plus 0 is 6, 3 plus 2 is 5, and 5 plus nothing is 5. So our answer, total number of toys, is going to be 5,561. And I would love, love, love it if you are checking my work. And if I make a mistake, just let me know. All right, now number 3. Here's some fraction review for us. Determine whether each expression is equal to 7/8. So we're looking to see if it's equal to, which also means equivalent to. So each of these has to be equal to 7/8. If it's not, we're going to check mark not. If it is, we'll say it is equal to. Okay, so let's go ahead and start with the first one. 1 plus 7/8. Okay, so 1 plus 7/8. Is that equal to 7/8? Well, what I know about a whole is there are parts living inside of this, and because it's a whole, I can choose to represent that in any fraction form. So I'm going to say this is 8/8. This one is 8/8. So if I add 7/8 to that, that is definitely not going to be 7/8, but let's check. 8 plus 7 is 15. That's 15/8. So no, 1 whole is not equal to or 1 whole plus 7/8 is not equal to 7/8. All right, let's do the second one. 4/8 plus 1/8 plus 2/8. Is that equal to 7/8? Let's see. Well, first of all, if we're adding fractions, we know that the rule is our denominators have to be the same. Is that the case? Yes. So then we can just add what's on top to see if it equals this. So 4 plus 1 is 5, plus 2 more is 7. So all of this together does equal 7/8. So we can go ahead and mark right here, equal to 7/8. All right, last one. 1 minus 1/8 equals 7/8. All right, so remember our 1 just means a whole, and that can be broken up into any whole fraction. So because this is, the unit is eighths, that's what I'm going to stick with. So 8/8 subtract 1/8, and sorry, this kind of looks like a 7, but it's a 1. And I'm trying to figure out if that equals to 7/8. So what I know also about subtracting fractions is the denominator has to be the same. Yes, it's the same, so then I can just subtract up top. 8 minus 1 is 7, and my denominator stays the same. So is 1 minus 1/8 equal to 7/8? The answer is yes. All right, number 4. Mark an X on the line segment SD. So a line segment is a portion of a line that has 2 endpoints. So it's not a continuous line that keeps going. There's a stop and an end. Okay, so that can either be in this form or, for example, a shape. So all of these lines have endpoints because they stop. They're not continuous. They don't keep going. Okay, so SD, I'm just looking for the ones that's labeled SD. So this is SJ, JY, YD, and DS, or SD. That's the line segment I'm looking for. So I'm going to mark an X right there, and I'm done for that one. All right, number 5 is 33 prime or composite. So 33, how do we figure out if a number is prime or composite? We think about what are the factors of that number that can go into it. So a number is prime if only 1 and the number itself can go into it. Okay, that would be prime. A number is composite if more than just the number 1 in itself can go into it. Well, I know that 2 can't go into 33 because 33 is an odd number. Okay, so let's try the number 3. Well, 3 times 11 is 33. So I know that there are more factors than just 1 and 33, so this number is composite. And I don't have to see if there's more factors than that because it doesn't ask for all the factors. It just asks for it to be if it's prime or composite. So once you find more than 1 and the number itself, you can go ahead and answer that question. All right, guys, last one, number 6, compare. So we're thinking about less than, greater than, or equal to, okay? The following values. Value is just how much something is worth, or how much something costs, or what's the size of something, how big or small it is. So we're thinking about what's the value of this number, which number is going to be bigger or smaller. So we have millions here. 7,410,623. So I'm going to go ahead and write that here. And sometimes when we're comparing numbers, it's really helpful if you line them up. So I'm going to pause the video real quick and do that. All right, guys, so I went ahead and wrote both of my numbers here. 7,410,623, and the second number, 7,416,023. So because I lined them up specifically using the place value according to their place value, so if I had a chart here, they would be all lined up, and I can clearly see if I start at the biggest number, they both have 7 million, they both have 400,000, they both have 10,000, 10,000, and then here's the difference. I'll use another color. Right here, this has 6,000 and this has 0,000, so this number is bigger. I'm going to go ahead and write a greater than sign. All done. Great job today. That's our wrap up for Lesson 28, Math Review.